All right, here we are, the beginning of geometry, and we're on section 1-1. This section right here, the very first one, talks about these three things, obviously, points, lines, and planes, and they call these things undefined terms. So I'll write that down. There are three undefined terms. So we don't really have a definition for them. But if you look in the book on page 5, it's right at the beginning, it's even highlighted where it says undefined terms. It says, because they're only explained using examples and descriptions. So that's all I'm going to do. I'm going to describe what a point is, a line and a plane, but I'm not really going to have an official definition for it. So let's talk about a point. A point is just one place, I guess if you want to say it, one spot, okay, in space. So it's just one particular place, and we represent it by just using a dot. Okay, so when we use a dot, that represents a point. A point. Now you actually are probably familiar with point, line, and plane. For instance, if you had remember this XY coordinate thing, you did this in algebra and geometry. Well, you're in geometry now, aren't you? So you haven't done it yet in geometry. All right, but you did this in algebra. And these would be two lines. This would be your x-axis, your y-axis, and you have points. You got a point right here, a point right here, and you can even, let's see if I can move it around a little bit so it hits both of those points right there. Raise it up just a tad. There we go. All right, so I've got a point right here and a point right here. Well, what do those 2 points make when I connect those 2 points? They make a line. So you've talked about these before. And look what it's in. It's in this thing called a coordinate plane. And again, these are things that you've discussed in Algebra 1. And we are just talking about them again here. So it should not be unfamiliar to you. And you probably remember how to label those points on that coordinate plane. So right here, we are going to call this point right here. It's just a representation. A point actually doesn't have any width, any height. It doesn't have any size at all. All right, it doesn't have any size, but we represent it by putting a dot. Now, I could actually, if I blew this thing up, I could actually blow it up, meaning enlarge it. Okay, if I made it a little bit bigger, you could actually measure it. It has a height, it has a width. Now this is on a computer screen, so it really probably doesn't have any depth to it, but if you put a point on a piece of paper using your pencil, it would actually have a little bit of depth to it. So you could actually measure those technically, but when we're talking about an actual point, this just represents a point. It's not actually a point itself. So, and that gets a little bit theoretical. We won't worry too much about this, but how do we label? That's what I really am concerned that you learn in this first lesson, is how to label these things. That's going to be the most practical thing that you get out of today's lesson. How do we label this thing? Well, we label it with a capital letter. You could use any capital letter that you wanted. I use A lot, A, B, C. So I'll just call it A, point A. So I would call that point A. It's just a little tiny circle with a capital letter next to it. Not a lowercase letter. It's pretty important that you put a capital letter because we need to make sure that we're on the same page when we label all this stuff. So that's how you label a point, with a capital letter. Now, what if you had a couple points next to each other? Well, they don't have to be right next to each other, but if, let's say I had a point right here and a point right here, and I actually connected them. Actually, let's make this go through a little bit, and I could go through like that and make these dots a little bit bigger so they kind of stand out. All right. What if you had this? What if you connected those 2 points and you kept on going in one direction, you kept on going in another direction, and we show that by arrows? Well, we call that thing right there, we call that a line. Oops, if I could spell correctly. There we go. That thing right there would be a line. A line is made up by at least 2 points. You have to have at least 2 points to make up a line. Now, you could have more than 2 points on here, and in fact, a line is an infinite number of points, of course, and we're not going to label every single point, because if you tried to label an infinite number of points, you'd go forever and ever and ever, infinity, and that would be impossible. So we're going to have at least 2 points. At least 2 points make up a line. How do we describe the points again? We use capital letters with this, so we'll call that capital A and capital B. So if I have a point A and a point B, and it's connected by this straight line, then we call that thing a line. Now, I said straight line, and I might say that every once in a while, but a line is automatically straight. So if I say a straight line, it's kind of being redundant because a line is already straight. I was going to say by definition, but these are really undefined terms. But the way we describe them, a line, if I say a line, it's always straight. Anything like this would not be a line because it's not straight. All right. So we name, or we use 2 points to describe a line, at least 2 points. Okay. You could have more than 2 points on a line, but if we're going to name it, you're only going to use 2 points on that line. So how would I name this line? Well, I'm going to put the 2 points right next to each other. Call it AB. Now, I could put the word line out in front of it, but there's a better way to do this, and this is how they write a line. Instead of writing the word line out in front, we do this. We put a little line with 2 arrows on the ends, and we would call that line AB. So here's your picture. This is how you label it. This is the labeling of this situation, of this picture right here. We label it line AB. Now, you could also, it doesn't matter that the one on the left has to be A and the one on the right has to be B. It makes no difference. I could have used any 2 letters that I wanted to. And it also doesn't matter what order we put the letters in, all right? As long as you have 2, you're not going to name a line with 3 points, all right? Do you hear me on that? Do not, write it down somewhere, do not name a line with 3 points, only with 2 points. A lot of people do that. They'll see 3 points on here, which I'll do in a second, but we don't use all 3. We only pick 2. 2 points for a line. Hope I got that straight. So we could call this line BA. It's the exact same line. It's no different. This and this are the exact same thing. It's just how we name it. This is line AB, or you could name it line BA. And there's really nothing else you can name that line the way it's labeled right now. Just call it AB, line AB, or line BA. Now, if I was going to read off the answers, or I ask you to read off the answers, and you saw this written in the book, you wouldn't just say AB. You would say line AB. And that's how we label the line. Now let's do this. Let's put another point somewhere in here. Let's just put it right here, and we'll just use the letter C. Now I have 3 points on this line. Does that mean that we name this line ACB? No, because remember what we said, we only use 2 points, and it doesn't matter which 2 points we use. I could have 20 points all labeled with all different letters, and I wouldn't use all 20 points. I would just pick 2 of them. It doesn't have to be like the first one and the last one. It doesn't matter. Just pick any 2 points, and you can name this line. So what else could I name this line right here? I could name it AB or BA. That would still be okay. Even though I stuck the C in there, I could still call this line AB or line BA. But there's a couple other options I could call this as well. I could call this line AC, because that's 2 points on this line. I can pick any 2 points on this line. What else do you think I could call it? I could call it AC, or, well, I could go backwards, couldn't I? I could call it CA if I wanted to. What other options do we think we have? Well, I got C and B, don't we? So we could put those together. So I could call this line CB, or I could go backwards on it and call it line BC. Look, I've got 6 different ways to name this line right here. Any of those 6 is perfectly fine. I could use any of those 6. It doesn't make any difference. Now, to tell you the truth, if I was going to name this, I probably would pick this one. That would probably be my favorite way to name it. Does that mean it's any more right than the other ones? No, obviously not. But most of the time, if I'm going to name a line, I'll take the first one that's labeled and the last one that's labeled and put maybe probably the first one first, the last one last. But you don't have to do it like that. You can do it any way that you wanted to. All right, I think we've exhausted that thing right there. Oh, no, we haven't actually. Let's do this. Almost forgot. Here's another way we can name a line. Let's drop this down a little bit, and let's make a line right here. And the line doesn't have to be straight across. It could be slanted. It could be up and down. It could be all kinds of different directions. All right, so let's say our line is right here. What if I don't have any points on here? What if I don't know any points? Now, there's a bunch of points on here. Don't get me wrong, okay? There's an infinite number of points. There's too many points to even count. That's what infinity is. But they're not all labeled. In fact, none of them are labeled. So what if none of the points on here are labeled? How could I name this line? Well, a lot of times they'll do this. They'll use just a lowercase, and they kind of make it cursive looking, a lowercase letter to name the line. If I have no points actually on the line itself, I could just say that's line A. See, it's a lowercase a. It's not a capital A. And it's outside it. It's not right on it. I don't put a dot. I could have put it right here, or I could have put it down here. They usually put it near where the arrows are. A lot of times they'll name it line L. It just seems like books kind of like to name the line L, probably because L and line. But they could name it M and P and Q and R. Those are kind of the most popular ways that they name it a line with just one letter. So if I was going to do this, I would not put a L and a line over top of it. That's not how we would do it if we just use one letter. What we do when they use just one letter and it's a lowercase, they actually do write the word in front of it, okay? So if it's a lowercase letter and it's just one letter on the outside, we're going to name it line L. We actually write the word out line. We don't put the little symbol over top of it. Okay, I hope that makes a little bit of sense. And that's on the book too. They use P, Q, and M for that, but I just decided to use different letters. All right, let's go on to another shape. And let's see if I remember my shape thing. Oh yeah, over here. And we'll do this. And a lot of times this next thing, they slant it. So I'm going to do this to it. Let's make that 20 degrees, and there we go. This is kind of like the common look for what we're going to talk about now. And you should know what we're going to talk about because it's points, or the label of our lesson is points, lines, and what else? Planes. So this is a plane. Not an airplane, but a geometric plane. Basically, if you want to think about it, remember, this doesn't have a definition. We just kind of describe it. We show it with descriptions or examples or pictures, and that's what I'm showing you right here. A plane is actually an infinite number of lines going in all directions. So it looks like we just have a line here, 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 and here. It looks like there's 4 lines, but it's really not. It's actually all the lines in this space right here. So for instance, if you took like the cover of your book, okay, the cover of the book would be one plane. All right, the tabletop that it's sitting on would be another plane. The wall would be a plane. The ceiling would be a plane, or they're representations of planes. But a plane, if it's made up of a bunch of lines, the lines keep on going forever and ever. Remember that? We got arrows on the ends. It keeps on going forever in both directions. Well, a plane does the same thing. A plane keeps on going. But I couldn't keep this going forever and ever and ever because then you'd never see what it looks like or the representation of it. So we do draw these edges to it right here. All right. It doesn't mean it stops right here. It doesn't mean this is the plane and this is not the plane. This keeps on going forever and ever and ever. All right. I hope that makes a little bit of sense to you. How do we name the plane? Well, we name the plane with a capital letter, but we usually put it in one of the corners. And the book, if you see in the book, they kind of make it like a fancy looking letter. I'm not going to draw a fancy looking letter, but they do it. If you look in the book, you'll see what I'm talking about. It's not really italics. It's just, I don't know, it's just a weird looking different font. But they put it in one of the corners, all right? It doesn't have to be in the top right corner. It could be any of the corners, and I would call this thing plane K. So I put the word plane. There's no symbol or anything that you write for it. You actually write the word plane, and then you put the capital letter next to it. I could have called this anything that I wanted to, but the example in the book uses this. Now, the plane is made up of a bunch of lines, but it also has a bunch of points in it. Now, when I say a bunch, I mean a bunch. I mean an infinite number. But they're not all labeled. But the book decided to label 3 of the points. And we labeled them B, C, and D. So here are 3 points that are on or in this plane. And that's a pretty important thing to do too, because or to say, because you need to know, like if I was going to say point B is on plane K, you need to know what I'm talking about. And that's what's going on right here. This point is actually on the plane. So for instance, if you had your like book cover and you put a dot, don't do this, but if you put a dot with your pencil on the book cover, that would be point B, and that's on the plane, and their plane would be your book cover. Right? And then I've got 2 more points right here on the book cover as well. Now, in order to make a plane, you must have at least 3 points. If you only had 2, that would not make a plane. You have to have at least 3 points, now get this, that do not lie on the same line. So all 3 points cannot lie on the same line. Now, I could connect a line between B and D, between D and C, and between B and C, but that would not be one line that contains all 3 points. All right. I hope that makes a little bit of sense. So in order to have a plane, you have to have 3 points that do not lie on the same line. For instance, let's say I actually had a line in here. Okay, I had a point right here, I had a point here, and I had a point here. And I call this X, Y, and Z. All right, if that's all I had labeled, could I say that that makes up a plane? No, I couldn't, because they all lie on the same line. All right, in order to have a plane, I have to have 3 points that don't lie on the same line. And B, D, and C all do not lie on the same line. All right. What do we call? We have a name for this, by the way. If I have 3 points that do not lie on the same line, you know what? I'm going to do this. Let's put this back up here. Let's backtrack just a little bit. What if I actually did have 3 points that lie on the same line, like we had up here? Do you remember this right here? A, C, and B. If I have A, C, and B, they all lie on the same line. I should have probably said this up here, but we call that collinear. 2 L's, C-O-L-L-I-N-E-A-R, collinear. Co, I think, means with, all right? That's the prefix. It means with the line, okay? Or they all make up that line. So these are collinear points. So what do you think these 3 points are? B, D, and C. B, D, and C, let's write this in the same color so these are together. We would call them non-collinear points. All right, so these would be non-collinear. And I'll just write points in here. So B, D, and C are non-collinear points. What if I asked you what X, Y, and Z were? They all lie on the same line, don't they? All 3 of those points. So I would call them collinear points. These are non-collinear. These 3 right here would be collinear. And it takes 3 non-collinear points to make a plane. All right. Let me pause for a second and grab a picture for you. All right, what we're going to do with this picture is we are going to just kind of look at it and see what's going on and name some stuff. All right, first of all, what would the name of this plane actually be? What would the name of the plane? It rhymes. Now, if you look at it, remember what we do is that fancy looking letter. It's in the corner somewhere. So where do you see a fancy looking letter in the corner? Hey, how about right there? Okay, that's a fancy looking letter in the corner. So I would call this plane P. All right. Oh, you know what? I almost forgot. How about this? Remember I talked about those 3 non-collinear points? I could actually name the plane with those 3 points. So I could name it plane K because that's that fancy looking letter up in the corner. Or I could take any 3 points that lie on this plane, any 3 non-collinear points. I could not call it plane XYZ. But I could take any 3 points that do not all lie on the same line, and I could call it that plane. So I could call it plane K, or I could call it plane BDC. And again, it doesn't matter what order you put those letters in. Now, you don't put anything over top of it. You just write the word plane in front of it. Then you put 3 non-collinear points. There's a lot of other options on this, too. I could have called it plane... What are 3 other non-collinear points? I could have used X. I could use Y. Now, they lie on the same line, but if I pick the third one that doesn't lie on that line, then I'm good. Let's say B. So that would be another name for the plane. There's a bunch. We're not going to name them all. But what would another name for the plane be? How about like ZDC? How about that? ZDC. Because they're 3 non-collinear points. Not all 3 of them lie on the same line. The only way I could not do this is if I said XYZ. Some of you might be looking at it and say, what about BZC? They kind of look like they lie on a straight line, but if the line isn't actually drawn on there to connect them, you can't assume that they would make a straight line. All right, so I could say BZC, plane BZC. All right, let's go back to that picture. So what could I name? What else could I name this plane? Could I name this plane VWX? Or WXY, or VXY? Could I name it any of those? Nope. And why not? Because those 3 points lie on the same line, and I have to use 3 points that don't lie on the same line. So give me 3 that don't lie on the same line. Well, we could name it plane, let's see, how about V? And what other one? Let's use W. And you're like, okay, well, wait a minute. Those lie on the same line. But as long as we pick the third one that doesn't lie on that same line, we're good to go. So I could call it VW, let's say Z. And that's really the only option. VWZ. It's the only other option for that third point. Or If I wanted to, there's other options I could call it. I could call it WXZ, couldn't I? Put the plane in front of it. I'm not going to right now, but WXZ, because look, all three of those don't lie on the same line. Does that make sense? Or I could go XYZ, or I could go VYZ, or WYZ. You know, there's all these different options that you could use for this. I'm not going to write them all down. Hopefully that makes a little sense. Look at point T, though. Is point T on the plane? The plane's in a nice blue color right here, but T actually is not on the plane at all. Okay, it's off the plane. So, for instance, if you had like the cover of your book and you like jam your pencil in the middle of your cover and it was able to stick there, okay, it's kind of sticking up. It's not lying right on top of it, it's sticking right up. And so this point T would be lying on your pencil that's not on this plane. Now, if you took that plane and laid it straight down, flat on top of your cover, that would be this line right here, okay? But this T does not lie on the plane, so, or this point T is not on the plane. Z, of course, is. Let's see, we could name this line right here, couldn't we? Let's name this line. I could name it all kinds of things. I could name it line VW. I could name it VX, VY. I could name it WX, WY. I could name it XY. Or I could go backwards with those letters. Remember, it doesn't matter what order that we put them in. Okay, so I've got all those options to name that line, this line right here. I could name it a whole bunch of different things, and it's the exact same line. What's another way, without using the points, that I can name the line? Well, remember that little lowercase letter? I could just call this line line N. So I would write line N, and that's a lowercase. Okay, or I could say V. I'll write a couple of these down. I could say VW. I could say WX, and I labeled them all, or I named them all before. You can write them down if you want. There's a bunch of things we could call it. All right, so we took care of those things. What about this line right here? Look at this. And what's up with the dotted stuff on here? Okay, we didn't introduce any dotted lines. What's going on with that? Remember when I said stick your pencil in your cover? Well, don't do it, but okay, imagine that you stick your pencil in the cover and it's sticking straight up and down. That's what's going on. Guess what that dotted line represents? This represents the part that you can't really see, all right? And it's kind of going out the back again, all right? So depending on what the angle is that you stick it through here, and this is where it goes through. This is where your line goes through. So we would say that all these points, V, W, X, Y, and Z, lie on the plane, okay? But T does not lie on the plane. And look at this line right here. Look at line TX, or you could call it line R. Let's call it line TX. Does line TX lie on the plane? No. This line lies on the plane. This line does not. What it does, it hits the plane at one point, and we call that an intersection. Okay, when they touch each other, when that at one point, when this line right here, line R, when it touches plane P, it hits it just at one point. This line, VY, or line N, it hits it at an infinite number of points. All right, I hope that makes sense. I have a little video demonstration just to show you. I think I just made it up. I just thought of doing this, so it's a little silly, but hopefully it'll make sense of what you were just looking at. So let's take a look. All right, here's just a piece of cardboard, and it's a plane. That would represent the plane. And now in my hand, I have just a little wire that represents a line. That would lie on the plane. Okay, see how it's all touching? Doesn't matter how you turn it around, or that's touching. That line would be on the plane. But what if I did this? What if I stuck it through that hole, jammed it through, and look what's going on? See, it's going through the plane, or it's intersecting the plane. Remember the dotted line part? See right there where you can't really see the wire? That's where the dotted line is represented, then it comes out the other end. So it doesn't lie on the plane, it intersects the plane, or it goes through the plane. All right, and how many points does it intersect the plane? Just that one point right there. That's what's going on. Let's just finish this up. So you can see it going through. All right, and that's what's being represented by that picture right here. It's exactly what's that wire's hitting the cardboard. It's hitting at one point and it's going all the way through. All right, let me show you something else. All right, check this thing out. These are two planes, plane A, the green one, and plane B, the blue one, and you have they actually intersect each other. Okay, think of having two pieces of cardboard and putting them next to each other, and they actually intersect. So how do these two planes intersect each other? They intersect each other at a what? At a line. All right, and that point of intersection is line R. Sometimes they'll do this. Let me use a color that'll stand out, the red. Sometimes they'll put a point here and a point here. Let's call this P and let's call this Q. All right, this is point Q and this is point P. Sometimes they'll say, name the intersection of the two planes A and B. Well, you could say it's line R. Line R would be the intersection of the two planes, or you could say it's line PQ. All right, it's line PQ. So if you had a question, and I believe you have one on a quiz or a test or something, if I remember right, it says name the intersection of the two planes, and you would say, you wouldn't just say a line, you would actually name it because it says name it. You could say line PQ, or you don't have to put them both, but one or the other. You could put line R. So that's the intersection between those two planes. All right, this is one of the examples in the book. It's on page 7. I just copied and put it right here. So let's take a look at this and maybe answer some questions about it. If you can follow along in your book if you want. One of the first questions says, how many planes appear in this figure? How many planes? You could pause it if you want and try to count up how many planes that you actually have. Let's think about it. You've got this flat plane that it's sitting on, so that's one. And then you've got all the different faces to this figure. We'll talk later on in the book what this figure is. But you have all the faces to this figure. Let's see how many it has. It's got one right here in front. It's got two, this one right here. It's got this one in the back. Do you see that with the dotted line? That's 3. You got 4 right here. Let's see, 1, 2, 3, 4, 5. Am I counting right? Let's see, 1, 2, 3, 4. There should be 5 faces of it. 1, 2, 3. Oh, yeah, okay. Oh, my goodness, I almost didn't see it. Let's do it again. We got the bottom, that's 1. Then we got this face right here, the front, that's 2. Then you got the side one and this side one, that's 2 and 3. Then you got the 2 back ones, that's 4 and 5. So 1, 2, 3, 4, 5, 6. Oh, my word. I can't count. Let's try it again. Let's just forget the bottom. Let's just do this figure right here. You're probably saying, you are crazy, Mr. Hamrick. I see it right away. Why can't you see it? I don't know. Sometimes I just don't. Let's look at it again. You got the front. That's 1. Then you got this side. That's 2. Then you got the back left side. That's 3. Then you got the back right side. That's 4. And then you've got this side right here, and that's 5. And you got the bottom, and that's 6. Whew. Boy, that was harder for me probably than it was for you. So there are 6 different planes that are represented right here. And if you wanted to name them, how would you name them? Let's take a look at this bottom one. You could just say it's plane X, couldn't you? Or you could pick 3 non-collinear points, and there's all kinds of different possibilities for answers for this. You could say it's plane HEG, just end it right there. Or you could, any 3 points that are actually on that particular plane, EGF, right? What about that front plane right here, this front face of this figure? What do? Well, you just pick 3 points that actually lie on there, and there's only 3 that are shown, D, H, and G. So I could call this plane DHG. Even though it's not like a 4-sided figure, it doesn't have to be. It just has to be 3 non-collinear points that make that up. Okay, what about this one right here? I could call it DJH. But they stick another, it looks like just a random point right there. So I could call it DJH because that's 3 non-collinear points, or I could call it KJH, or I could call it DHK, all right? Doesn't have to go in order or anything. So as long as I have 3 points that are represented, you could do that for the rest if you want to. Oh, those answers are in the book so you can see. It also says, name 3 points that are collinear. That means 3 points that lie on the same line. What about this line right here? No, I only have 2. I only have 2 here, 2 here, 2 here, 2 here. I only have 2 on this one. Where do I have 3? Remember that one where I look kind of like a random point? D, K, and J are the only 3 collinear points, the 3 points that lie on the same line. That's collinear. Now it says, name the intersection of plane HDG. Let's find HDG. HDG. So it's this front-facing plane right there. So name the intersection of that plane and plane X. All right, and plane X is the bottom of it. So where does it intersect? Where does this plane right here that's shaded in intersect with the bottom? Well, it intersects right here. That's where it intersects, right there. And what is that? It's 2 points, so it's a line. So it intersects at line HG. G. That would be your answer. And how would you write that? You would write HG, and you would write the line symbol over top of it. All right, we're almost done, I promise. This is a little longer than I normally want to go, but we're getting through everything here. Last one. It says, at what point do lines LM, let's find LM, that's this one right here. Okay, this whole thing, it's not just from here to here. Remember, it keeps on going forever. So this whole line that's intersecting that plane, all right, it says, at what point do line LM and EF intersect each other? And what was it? EF. So LM and EF. EF, that's this one right here. Okay? Does it even look like they intersect each other? For instance, if I took this and I stretched it out like that, let's make that a little thicker. All right. Does it intersect this line? You're like, yeah, it intersects right here. But let's think about this. Remember, what does this line do? It goes through that plane at this point and it hits the back of it. So really, does this red line right here intersect this up and down line right here? No, they don't intersect each other because that represents that it goes through the back end of it, and this is actually on top of the plane. So these do not actually intersect each other. So it was a little bit of a trick question. All right, so there you go. I think there's one more thing I want to tell you because they don't really describe it in the... Actually, I've got the picture right here, so let's just put that here. And they have a couple questions in the problems that I'm going to give you. And let me put this right here. And they talk about a box, and they talk about the edges of the box. So I just wanted to make sure you understood what they're talking about when they talk about the edges. All right, see from here to here, this would be one edge of the box. And then this would be another edge of the box. This would be another edge. All right, I think you get the idea what I talk about when I talk about the edges of this. Now, where they intersect, they call that the vertex. All right, so when these lines intersect each other at this point, they call that the vertex. Okay, it's a point of intersection, but it's another word that they, I think they ask about, but they don't really tell you in the lesson itself. All right, so that's just a little bit of a helpful hint when it talks about the edges of a box. All right, that's about it. Let me get your homework assignment, and then you'll be ready to go. Okay, let's do page 9. Oops, that's a little thick, isn't it? Let's tone that down. There we go. So let's do page 9. Now, this is going to look like a lot, but they're actually kind of easy. Okay, let's do 13 to 48. It seems like a lot. But a lot of these is just looking at something, writing down a quick little answer, not that really big of a deal. There is a section in here that we didn't really do, but you can kind of figure out yourself, I believe. And that would be numbers 32 to 39. They actually tell you something, you have to draw it. We kind of did the opposite. I gave you a picture and we described it. On this one, they give you a description in words and you actually have to draw what they ask you to do. So that's a little bit tougher, but everything else is pretty basic. You just look at it and just write down an answer. There's no really figuring out. There's really not much work to show on this stuff, and I really do emphasize that you show your work. On this particular lesson, there's really not a lot of work to show. You basically just look at it and write down an answer. All right, so when you come to class the next day after watching this, you guys can work on this in class, and of course I'll be there to help you out, and you'll have people around you to help you out as well. All right, so that was our very first lesson, and see how that goes. All right, take care. Bye.